Well, welcome back. Okay, here we go on with part two. What I want you to do again, anything in white, you got to write. So continue writing it down on the piece of paper. Just continue on the same piece of paper, all right? So, where we left off, as I'm sure you recall, since it was just a minute or two ago, let me grab hold of my thing here. There it is. Okay. So this is where you left off. Basically, you should have now written down the steps in the scientific method: question, hypothesis, experiment, data, conclusion, and report findings. Now we're going to go on to the whole idea of what are these things? Let's practice it a little bit. And we could get real exotic and that kind of stuff. We'll be doing labs and using these steps over the next few weeks. But let's start off with, here's something. This is probably the first time we've come across this. If it's written in white, I'm going to want you to write down the text, okay, and have it in your notes. Sometimes I'll have other stuff that's written in yellow, and you don't really have to write that part down. Okay, I guess you can if you want. And anytime it goes too fast and you can't write something down, and just pause the video, right? But this you don't have to write down because look, it's in yellow. But this is an important idea. Really, the scientific method is just a formalized way to use a thought process we use in day-to-day life. Honestly, the scientific method is not super exotic. It's just very deliberate and systematic. But it's the way we think about stuff and problem solve all the time, really. And so let's just do a couple of mundane day-to-day kinds of examples. Okay, so now I am going to want you to write these down again. You already wrote it once, write it again, because we're going to fill in examples of a question and a hypothesis and experiments, right? So now it always starts with a question. So write this down: question, hypothesis, experiment, data, conclusion, report findings. 1, 2, 3, 4, 5, 6. If I'm going to go too fast, pause the video or come back to it, because I'm going to move on right now. So it always starts with a question. And in life, different kinds of questions come up. Big, huge questions. How the universe and how far away is the sun or whatever it is. But there's also just day-to-day stuff that happens. And for example, let's say, where's my cell phone? Now that might be a question that you guys ask yourself 3 times a day. I do. Where's my keys? Where's my cell phone? Where's my wallet? And you think about your thought process there. It's called being metacognitive. Let's say you go, okay, I need my cell phone. What? Wait a second. It's not my, where's my cell phone? Right. And you want to find it. So the first thing that happens is you kind of cogitate on it a little bit, and an idea pops into your mind, and you go, oh, I bet, see that? Where's my cell phone? Write that down right where you wrote question. Now we're going to fill in a hypothesis. A possible answer to the question is called a hypothesis, right? And so, where's my cell phone? Well, I think it's in my jacket pocket. Like maybe I left it there. And they think, okay, that's a possible answer. So now that you have a possible answer, now when we're writing science labs, I don't want you to write, I think, blah, blah, blah. But for now, I'm putting that to stress. What this is a possible answer that you think is probably it. Normally, when you state a hypothesis, you would just state the idea. It's in my jacket pocket. But like I said, since we're going through that thought process of it, sometimes they call it an educated guess. Yeah, okay, that's fine. But really what it is, it's a possible answer to the question. Where's my cell phone? I think it's in my jacket pocket. Maybe I left it there. So write that down as a possible hypothesis. Now, you want to design an experiment to test whether this hypothesis is correct. What could you come up with as an experiment to test that hypothesis? How could you find out if it's in your jacket pocket or not? Yeah, that's right. Duh. You go look in your jacket pocket, right? You go up to your jacket, is it in there? And you reach in the pockets and that kind of stuff. That is an experiment. An experiment doesn't have to be something where you're mixing test tube chemicals or make whatever. That anything you're doing to find out if your idea is correct here is an experiment. You're trying to get information from the world. Remember, this is what you're trying to do. It's go beyond a matter of opinion. Oh, it's my opinion that it's in my pocket. Yeah, you can have that opinion all day long, but you know what? Maybe it's true, maybe it's not. That's the thing about science, is to sort of differentiate between opinion and fact and what's really happening in the world. And so an experiment you have would be, okay, what is it? Say it out loud. What's the experiment? There you go. Look in your jacket pocket. Go ahead and write that down. Yes, that's an experiment. This is the thought process using the scientific method. Okay, and you look in your jacket pocket and, what happens? Well, in this case, let's say, no, it's not there. Okay, so you just conducted an experiment and you got data. And this data, sometimes it's called falsifying your hypothesis. It turns out your idea was wrong. Sometimes it's called, confirming your hypothesis if it's correct, falsifying or refuting if it's not. So anyway, your hypothesis has been refuted. So what's the conclusion? Your hypothesis was incorrect. Again, this is the beauty of science. And scientists are human too, and humans love to be right. But really what makes science progress and move forward is scientists are trying to find out evidence to test their own ideas, to see if their own ideas are right or not. And a scientist should be willing to accept when they're wrong, right? And so you can come up and get closer and closer to the truth. And here's an interesting thing. Sometimes people go, well, so they don't know for sure. They keep changing their minds. Scientists, first they say this, then they say that. But, that isn't really a reason to go, you can't trust science. Actually, that's why you can trust science, because they are willing to change their mind. It's when somebody's got something locked in there and I'm not going to change my mind no matter what the evidence is. Scientists are always trying to look for the evidence to find out if their ideas are correct or not. And that is the beauty of science. And that's how knowledge moves forward in our society, right? Now, report findings in this case, you might go, Mom, it wasn't in my jacket, or whatever. You're not going to have to write a formal lab report on this. But in the scientific world, they will report their findings. They'll publish the results, and then other scientists can read it. And by the way, this is something that's kind of interesting. Usually things that are kind of exotic or positive results, people tend to want to publish more. But, if the hypothesis is not correct, that's just as interesting, just as important, because that's when you learn something, right? Everybody wants to be right. But when you're not right, that's when you learn something. And so the idea of reporting negative findings is just as important as reporting positive findings. Okay, so there's an example using the scientific method for something like, where's my cell phone? Okay, so now you have to revise your experiment. Okay, now I've had you write that down. All this white stuff should be in your notes now. I'm not going to make you do that over and over. All right, but boom. Let's do another setup just as an example and walk yourself through this. Okay? The question now, it wasn't where you thought it was, so you still got the same question. Where's my cell phone? Now your hypothesis is going to change though, because it wasn't where you thought it was before. Now you come up with a new hypothesis. And let's say, think for a second, where could it be? Well, let's say maybe it's in your desk drawer. Okay, so, maybe it's in my desk drawer. And what's a simple experiment you could devise to find out? You guys know this. Easy peasy. Come on, say it. I want you to be thinking. Answer that question, because you're going to have to do that in a minute anyway. It's in your desk drawer. The experiment would be, yes, look in your desk drawer. That's an experiment to test whether your hypothesis was correct. And then as it turned out, it's there or not? No, it's not there either. Okay, so now you keep on going. So your conclusion is your hypothesis was incorrect. You're like, oh, man. And so report findings. Mom, I can't find this again, So what we're going to do next is you're going to do some examples where you fill in what a hypothesis would be that kind of stuff. Okay. And so you got some questions following here. Okay. Adios. Get to it.